Welcome. Here we're going to look at our last bit of information when we talk about the mole, and that's percent composition. So I'm gonna go through the PowerPoint, do some questions, and then at the very end, there will be a question that I'm gonna ask you to show me your work and send it to me. It's kind of like your attendance for the day. I don't imagine this will take you the full period to do. So let us begin. All righty. Well, percent composition, we do this by looking at the mass. So we want to remember that when we talk about mass, we're really talking about grams. That's what we're going to do. And I think you guys understand what percent composition is. We do it all the time when we think about scores on a test. But the actual definition is the percent by mass of an element in a compound is the number of grams of the element divided by the mass in grams of the compound multiplied by 100. So to me, that's a lot of words and a lot of gibberish. Let's get down to and let's really do a problem. So this is the one I think that we've seen a lot. If you got 90 out of 100 on your test, what is your percent? Well, most of us could just say, hey, that's 90%. And there it is. But how did we do that? So let me do this. And this is just like our problems that we do, is what we're looking for, in this case, 90, over our total, which in this case is 100, times 100. Not 110, 100. And that's going to equal our 90%. So now let's look at the next one. Say your test wasn't out of 100, because 90 out of 100 is kind of an easy one. What if we got a 78 out of 85? Well, the same idea, and the question is, which one's a better percent? 90 or 90 out of 100 or a 78 out of 85? So let's do our math. 78 is what we got out of a total of 85 times 100. Now I'm going to put this in my calculator. 78 divided by 85 times 100. And I get 91.76%. Well, I didn't know when I first started, but a 90% is not as good as a 78 out of 85. So that's how we find percents. We do it all the time in tests. Let's look at how it would look like when we do an element or a compound. Let me get rid of these. All right. So we're going to do this by mass. So we're going to use our periodic tables. You should have one with you. I will use our green periodic table. So here's our first problem. What is the percent composition of iron 3 oxide? Well, our first hurdle here is what is iron 3 oxide? And I'll give you that. There it is. Fe2O3. Now, it doesn't tell us what we're looking for. Are we looking for the iron or the oxygen? So we're going to find the percent composition of each element. So we're going to break it down into our F or Fe. Now, when we're looking at our compound, we have 2 irons, not just one. So we're going to take that iron times its molar mass, we find on our periodic table, and times that by 2. So 2 times 55.84 is 111.68. That's how much just the iron in iron 3 oxide is. But that's not everything. We still need the oxygen. So let's look at our oxygen. Now, how many oxygens do we have there? And again, let me point that out. We have our 3 oxygens. And the molar mass of oxygen is 16. So 3 times 16 is 48. Now, by finding those two, we find, and adding them together, we find the total. And that's a big deal here because we want to know what we're looking at on top divided by our total. So that 159.68 is our total. That's the maximum we can get. So I'm going to move our iron down. That's just the part of iron. And then we're going to divide it by our total, which was 159.68. Percent comp, percent means by 100. So times it by 100. And what do we get? You can do the calculations real quick. You get 69.97% of this compound is iron. Now, we still need to find oxygen, and you could do it the same way if you wanted to. You could take 48, because that's the amount of oxygen we have in there, divide it by 159.68 times 100, you get the answer. But if we remember that percent is out of 100, and there's only 2 elements in here, iron and oxygen, we could minus the 69.97 from 100 and get the answer. Either way is acceptable as long as I get the answer. So our final answer here in this problem is we have 69.97% iron and 30.03% oxygen. Now, if you add my percents up, they add up to 100. Sometimes because of rounding, we'll be really close, like 99.9. Totally good, but we really want to make sure we're really, really close to 100. All right. Now, I want to walk through this one also with you. So I'm going to write it on the board. You can follow along with your notes. So our first step is to break this up into its elements. So I have Fe, and how many Fe's do I have here? Only one of them. Each one is 55.84 grams. Double check. I like it. So that would be just 55.84. Now we have nitrogen, and this is a toughie. That 3 also goes to that nitrogen. So there are 3 nitrogens. Each nitrogen is around 14.0. So let's do some calculations. You can do it while I do it. 3 times 14 gives me 42. And last element in there is oxygen. Now this is where I think we really get confused. We don't add these, this is multiplying. So 3 times 3 is 9. And the molar mass of oxygen is 16. So 9 times 16 gives me 144. Okay, think, what do we need to do next? Yeah, you got it. We've got to add these together. So 144 plus 42 plus 55.84, I get 241.84 grams. Now I'm going to put this right here just to remind us. That's our total. Now we can go and find out how much of each element is, what percentage of each element is the total here. So what we can do is, I'm going to do it up here. Let's do Fe. And we know the total amount of Fe is 55.84 divide that by our total, and times by 100. Let's see what I get. 55.84 divided by 241.84. I get, times 100, I get 23.08%. Now let's look at nitrogen. I'm going to move nitrogen right below it here, and let's maybe change a color so we can see the difference here. But I have nitrogen, and there is 42 grams in that one over the total of 41.84. Now here's just a quick thinking question before we actually do our math. Do you think the percentage of nitrogen is going to be more or less than iron? Hopefully less, because 42 is less than 55.8. But let's see. 42 divided by 241.84 times 100 equals, I get 17.3, and if I'm rounding, 37%. Now, we can do the last one, oxygen, just like we did this, or we could add those two up and minus from 100. I'm going to keep going just so you can see this. Let's do dark green here. I'm going to move down a little bit. We have oxygen. We know there's 144 grams of oxygen in here, in a total of 241.84 times 100, and let's see what we get. 144 divided by 241.84 times 100, and I get 59.54. Now, just to make sure to see how close we are, I'm going to take those percentages and add them up. So I got 59.54, a 17.37, and a 23.08. To save me time, I'm going to plug these in my calculator. Hopefully I'm really close, if not right on to 100. 59.54 plus 17.37 plus 23.08. Ooh, just shy. 99.99. Is that good enough? Absolutely. That means that we should have a pretty good chance of a right answer. All right. If you need to, you can go back and look at that and get an understanding of it a little bit better. This is probably one of the most complicated ones, and that's for the fact that we got to make sure that we get the right number here. And that, again, is that 3 is multiplied by these numbers and go there. All right, so in class, I did it on the board and quickly showed it like this, and we're going to see that I get just about the same numbers there, so that's awesome. Now, here is your homework. First, find what is the percent composition of just carbon. So this one, we just have to do carbon. You do not need to do hydrogen. So on a piece of paper, show me your work with your percent comp. This would be question number 1 for you. And the last question, a little bit more difficult. Again, we need to see the work. I want the percent composition for all elements in here. So let me get you a start with this one. This would be your question number 2. We have Fe, and there is 1 of them. We have Cl, and there are 2 of them. And we have Br, there is 1 of them. So again, on a scratch sheet of paper or something, but once you get these, take a picture. I need 2 things. I need your work and I need your answers. And this will be turned in hopefully before the end of a class on Wednesday. Thanks for following along. I'll be back tomorrow. I can't wait to see you guys. Take care.